All right, let's get into it. Today we're going to put on our digital lab coats and do a full-on anatomical exploration of one of the internet's biggest unsung heroes, the TCP segment.
Welcome to SuperCore SEVA. Unlock the secrets of the internet and master computer networking. Let's dive in.
I mean, really think about it. You're downloading a huge game, maybe streaming a movie in 4K. How in the world does all that data get from a server halfway across the planet, navigate the absolute chaos of the internet, and then just reassemble itself perfectly on your screen? Well, the answer is hiding inside the tiny little package we're about to dissect. So, before we can put our subject on the table, we've got to understand the world it lives in. And the best way to think about data on the internet is like a set of those Russian nesting dolls. This whole idea has a name. It's called encapsulation. Basically, each layer of data gets wrapped inside another bigger layer. It's all for protection and, making sure it has the right address to get where it's going. The outer layers are the packaging, and deep inside, you've got the precious cargo. So, let's break that down. The biggest, outermost doll is the Ethernet frame. Think of it as the delivery truck that carries everything across your local network. Then, inside that truck, you've got the IP datagram. That's the cardboard box with the main shipping label on it. And finally, when you open that box, you find what we're looking for, the TCP segment. That's the actual contents. Okay, so we've carefully unpacked our TCP segment. Now it is time for the main event. We're placing its most important part, the TCP header, right here on our imaginary surgical table for a much closer look. You see, this header, this is the brains of the entire operation. It's made up of all these different fields, and you can think of them like tiny digital organs. Each one has a super specific, super critical job to do. They manage literally everything, from addressing to making sure things arrive in order, to flow control, and even checking for errors. So let's start our examination with the absolute vitals. This is the heart and brain of the segment. These are the fields that tell the data exactly where to go, and then make sure it all makes perfect sense when it gets there. First up, we've got the ports. Now the destination port, that's the easy one. It's the to address. It tells the receiving computer, hey, this data is for the web browser, or this is for your email app. But the source port is just as important. It's a temporary from address that your computer makes up on the fly, and it's the secret to how you can do a million things at once online. And this is exactly why it's so important. Just imagine you have 5 different browser tabs open, and they're all talking to the same website, right? Without a unique source port for each tab, a unique return address, how would the web server know where to send the replies? It wouldn't. This is what makes sure the data for that YouTube video ends up in the YouTube tab and not in your online banking tab. It's absolutely crucial. Next up are these two, the sequence and acknowledgement numbers. Just think of them as digital page numbers. See, a big file gets chopped up into thousands of these little segments, and they can arrive completely out of order. So the sequence number basically says, hi, I'm page 42 of this message. And the acknowledgement number is the reply that says, okay, cool, I got page 42. Go ahead and send me page 43 next. This is the real magic that makes the messy, chaotic internet feel so perfectly orderly to us. It just doesn't matter if packets take weird routes or get delayed. These numbers act as the perfect guide, letting the receiving computer just patiently wait, collect all the pieces, and then put them back together in the exact right order every single time. All right, let's move on to the next set of organs on our table. These are the regulators. Their job is to control the speed of the conversation and to make absolutely sure the message didn't get scrambled along the way. First is something called the TCP window. This is basically the internet's traffic cop. It's a number that one computer sends to another, and it says, hey, this is how much data I can handle right now before my buffer gets full. It's what stops a super fast server from completely overwhelming your phone or laptop with too much data all at once. Yeah, you can just picture the receiver shouting, whoa, slow down. My loading dock can only handle 10 boxes right now. Wait for me to give you the signal before you send the next batch. It's this constant back and forth negotiation that makes TCP so reliable and so efficient. So what about making sure the data isn't, broken? That is the job of the checksum. It's a fancy but very fast mathematical calculation that the sender does on the segment. The answer to that math problem gets placed in the header, kind of like a wax seal on an important envelope. So when the segment arrives, the receiver does the exact same math problem on the data it just got. And if its answer doesn't match the number that's in the header, well, that means something went wrong. Even a single bit of data got flipped somewhere. The segment is considered corrupt, and it's just instantly thrown away. The sender never gets the I got it message, so it just sends it again. It's a simple but brilliant all-or-nothing guarantee that your data is perfect.
And, of course, like any complex body, there are a few other parts. We can kind of think of these as the vestigial organs. The data offset is just a simple table of contents telling you where the actual data begins. The urgent pointer is an old priority flag that nobody really uses anymore. And then you've got options and padding, which are there for special situations and just to make sure all the bits and bytes line up perfectly. They're important, but they're not involved in the day-to-day grind.
Okay, our dissection is complete. We've examined all the key organs, we understand what they do. So what's our final diagnosis? What are the big takeaways from our little study here? Well, let's run through the checklist. We saw how encapsulation wraps our data up safe and sound inside an IP packet. We learned why the source port is such a critical return address for multitasking. We understood how those sequence numbers turn internet chaos into perfect order. We saw how the window acts as a traffic cop to control the flow. And finally, how the checksum guarantees with certainty that our data arrives completely intact. So the next time you click a link, stream a show, or send a message, just take a second to think about the billions of these perfectly structured little TCP segments, all doing their job flawlessly. It is a silent, microscopic, and frankly, incredibly elegant ballet of data. And it's the anatomy of this invisible package that truly makes our entire connected world possible.